Hello everyone, welcome back to another session. In this session we are going to solve some more important questions about derivatives. Then we're going to study some other things like slope of curve at a point, equation of tangent line. Let's begin. Previously we solved up to question 43. Now in this lesson we are going to continue because these questions are very important. They are covering almost all the ideas of finding derivatives. Question 44, fx equal to ln square root 2 plus cosine squared of x. Okay, we have this function. To find the derivative, again, there are many ways of doing it. One way is to make this square root power 1 over 2, and as a property of ln, power goes to the front, then the function will be easier as we get rid of the square root. Then as a rewriting step, this will be, this whole thing becomes power 1 over 2, and as a property of ln, power goes to the front, so it will be 1 over 2 ln 2 plus cosine squared x. Okay, now the function looks easier. Dealing with this is easier than dealing with this. Now, using ln, the rule of ln, to find derivative, it will be 1 over this times the derivative of this. Then f prime of x is equal to 1 over 2 plus cosine squared of x. That's the property of ln. 1 over whatever is inside the ln times the derivative of inside times derivative of 2 is 0. Derivative of cosine squared x is 2 cosine x times sine x times 1. Okay. Derivative of cosine squared is like derivative of the function times the derivative of inside. Derivative of cosine is power goes to the front, cosine as it is, times derivative of cosine, which is negative sign. Cosine times, we can add the negative here. Negative sign times cosine, it will be negative. I wrote the negative here instead of here. Then times the derivative of inside. Inside is x, derivative of x is just 1. Now, if we simplify this, we write this one up here. As we multiply any fraction by any term, we only multiply it with the numerator. So the answer is negative 2 cosine x sine x over 2 plus cosine squared x. And never do this mistake. This cosine cannot cancel this cosine. This 2 cannot cancel this 2, all because of this plus. Since the next to the 2 is plus, this 2 cannot cancel this 2. Next to cosine there is plus, this cosine cannot cancel this cosine. If it was times, they would, the 2's and the cosines would cancel each other. This is the answer. And to not forget, we had a 1 over 2 in the beginning. This 1 over 2 stays. So the 1 over 2 will be here, the whole fraction multiplied by 1 over 2. Now this is the f prime. This 1 over 2 that was in the beginning, it should be considered even here. We can multiply by 1 over 2. Then it's okay now. This question finished. Now question 45. How can we do derivative of exponential? Or simply, how can we do derivative of e? Fx equal to e negative x squared. E is a very good function. Its derivative, its integral would never change it a lot. It's like the function as it is, we write it once, times the derivative of the power. So derivative of this function, f prime of x is equal to the function as it is. e negative x squared times the derivative of the power. What is the power? The power is negative x squared. So derivative of it is negative 2x. Now simplifying, we write this one. Here, it's the final answer. Negative 2x e negative x squared. So the function as it is times the derivative of the power. This is how we do e, or exponential. 46. X squared e negative x. Fx is equal to x squared e negative x. Okay, as we cannot multiply them to be one term, we need to use the product rule. Product rule is like this. That's f prime of x equal to first times derivative of second. Derivative of second, since it's e, the derivative of it is like we write it once as it is, times the derivative of power. Derivative of power is negative 1, makes it negative, plus second times derivative of first, 2x. Now, let's simplify. X squared times this, it will be negative x squared e negative x, plus 2x times this is 2x e negative x. Usually in the multiple choices for such questions, since there is common factor, we can take e negative x and 1x as common factor. What's remaining? As I said before, the simplifying depends on the choices. If all the choices are written in this form, then you don't have problem. You can easily find the correct answer. But if the choices were written in the form of a bracket and e power x is outside, or if the choices were written in the form of fraction, then we need to simplify this 2 more steps. One step is x and e negative x, x e negative x, that's common. We can write x e negative x outside as a common factor. What's remaining here is negative x. What's remaining here is 2. Now, this part, since it has a negative power, it can go down. Then it will be x, ex. The x has no negative power, only e has negative power. Negative x plus 2, or 2 minus x, or negative x squared plus 2x. Anyhow, these are all correct, but which way the multiple choice is given would be your best way in the exam. Now question 47. Question 47. Fx equal to ln of a fraction. Ln of fraction, ln of division will be minus. We will have 2 different lns, between them minus. This will make the function look easier. Rewriting right away. So it will be ln, the numerator. When we make division, subtraction, when we rewrite this, the first one should be always first. 1 plus ex. That's it. Minus, its division becomes minus ln 1 minus ex. It's inside the ln. Now, since we have 2 different lns, between them is minus. Minus is okay for derivatives. We do this derivative minus this derivative. Derivative of this part, now it's f prime. Derivative of this part is 1 over 1 plus ex times the derivative of this part. Derivative of 1 is 0. Derivative of ex is ex. Times the derivative of the power, 1 will not change anything. Minus ln 1 minus ex. Okay, so it will be 1 over 1 minus ex times the derivative of inside, which is negative ex. That's it. Derivative of this part is negative ex times the derivative of power. Power is 1, will not change anything. Okay, now multiplying the e, it will be 1 plus ex, and up is ex. We cannot make this two fractions. We cannot say ex over 1 plus ex over ex. We cannot do this. We cannot separate denominators. This is negative, negative becomes positive, plus 1 minus ex, and up is just ex. Now if we need to simplify this more, we need to multiply both denominators together to make it 1. 1 plus ex, 1 minus ex. Multiply both denominators together, then this is the common denominator. This part that has this should be multiplied by this. And this part that has 1 minus ex should be multiplied by 1 plus ex. It's kind of like butterfly method. Now ex times 1 minus ex is ex minus e2x. When we multiply ex by ex, it will be ex power 2. And when e has two different powers, the powers will be multiplied. X times x, x times 2 is 2x. That's where we get from this. Plus ex plus e2x. Now, that's negative e2x. That's positive e2x. They cancel out each other. So the answer is 2ex over this. If we look at these brackets, it looks like difference between two squares, as the brackets are the same, but one of them is plus, one of them is minus. This is difference between two squares. These two brackets could be written as 1 minus e2x. Difference between two squares. 1 times 1 is 1 squared, which is still 1. But ex times ex is e2x. We can simplify this even more based on the multiple choices. Now, question 48. That's a good question. E has power. Power goes to the front, and ln and e will cancel each other. Or we can directly say ln and e cancel each other. Fx is just equal to x, and derivative of f at x is equal to 1. Ln of e is equal to 1. Then 1 powered by x is still 1. But look at here, ln and e always cancel each other. What's remaining is the power. There is another way of simplifying this, if this is not clear. As property of ln, power goes to the front. As property of ln, power goes to the front. So ln ex is like x ln e. You have calculator, it's always allowed. In your calculator, write ln e, you will see 1. 1 times x is just x. So fx is just x, and derivative of x is 1. Now 49. Two over ax plus e negative x. For this one, we can use the quotient rule, or we can make them all power 1, send them up. The quotient rule is okay. The quotient rule makes the denominator power 2. Denominator ex plus e negative x power 2. Numerator ax plus e negative x times derivative of numerator. Derivative of 2 is 0 times 0. So it is gone. Minus 2 times derivative of this part. Derivative of this ex is just ex. Derivative of e negative x is e negative x times derivative of the power, which is negative. So it's negative e negative x. This is the derivative. If we simplify this, it will be negative 2 ex plus 2 e negative x over ex plus e negative x all squared. There is simplifying, but we leave it here. It's okay. Question 50. fx is equal to ax times sine x plus cosine x. It's obviously multiplication between two functions. One of them is exponential, one of them is trigonometric. To find the derivative, we just go with the product rule. First times derivative of second. Derivative of cosine, derivative of sine is cosine. Derivative of sine is cosine. It's plus between them, then it's obvious. Derivative of cosine is negative sine. Since it's negative sine, the plus will be minus. Negative sine x. So what happened, it's first times derivative of second. Plus, this time, second, we write the bracket as it is. Sine x plus cosine x. Times derivative of first. Derivative of ex is ex. It's the same. Now, simplifying. This will be ex cosine x minus ex sine x plus ex times sine x is ex sine x plus ex cosine x. Do you see any like terms? Negative ex sine x plus ex sine x, it's 0. Ex cosine x plus ex cosine x is 2 ex cosine x. This is the answer of question 50. Now we're going to use derivatives to find slope. Actually, derivatives are slope, but when you find the derivative of a function, if we enter any x value, the result we get is slope of that function in this x. Look at this example. Find the slope of this curve at 316. Good. First of all, when you want to find slope, we need only x value. This y value is extra. Okay? Now, to find slope, we need to find derivative first. Remember, f prime of x, which is derivative, is equal to slope. M is slope. F prime of x is equal to slope. What's the derivative of this? Derivative of x squared is 2x. Derivative of 2x is 2. This is the derivative. Now, if I replace x with 3, I will get slope of this curve at this point. Now, replacing x with 3, 2 times 3, 6, plus 2, 8. This means slope of this curve at this point is 8. Since we can find slope, we can also find equation of tangent. What is equation of tangent? If we have a curve, let's draw. If we have a curve, okay, at any point we can find equation of tangent line. Tangent line is a straight line that touches the curve at only one point. Then tangent line is a straight line. To find equation of straight line, we need to know slope, we need to know one point. And tangent line, we can find this point, and we can find the slope. Then if we know slope and point, we can use the rule, equation of straight line y minus y1 equal mx minus x1. Then we can get the equation of tangent. Look at this example. Here, there is an example. In exercises 51 and 52, find the equation of the tangent line to the graph of f at the given point. This is a curve. This is a point. What should we do? We need to find equation of tangent line. Equation of tangent line is a straight line. Since it's a straight line, we need to know slope. We need to know a point. The point we already know. The slope, we have a way to find the slope. What is the way? Derivative. If we find derivative of this, then after we find the derivative of this, put 1 in place of x, what we get is slope. Let's go through the answer. Derivative of x power 4 is 4x power 3. Derivative of negative 3x power 2 is negative 6x. Okay. Derivative of 2 is 0. Now this is the derivative. If I replace x with 1, so it will be 4 times 1 power 3 minus 6 times 1. 1 power 3 is 1 times 4, it's 4. 4 minus 6 is negative 2. So slope of this curve at this point is minus 2. Now, I know slope, a point we're already given. Use the rule. Y minus y1 equal mx minus x1. In the point, this is x1, this is y1. x1, y1. So y minus y1, so it's y minus 0. Equal m, slope is negative 2. X minus x1, x1 is 1. Then simplifying this, y minus 0 is just y. Negative 2 times x is negative 2x. Negative 2 times negative 1 is 2. Then the equation of the tangent line is y equal to negative 2x plus 2. Similarly, question 52, a curve is given, a point is given. The question asks for equation of tangent line at this point. To find equation of tangent line, first of all, we need to find derivative. To find derivative, this function doesn't look easy. We need to rewrite it as something with a negative power to have an easier derivative. That is the function. If we rewrite, 2 stays the same. Quadratic root x power 3, so it will be x power 3 over 4. Goes up, x power negative 3 over 4. This is the function. Find the derivative. Power goes to the front. Power minus 1. Then 2 stays the same. Negative 3 over 4 goes to the front. Then negative 3 over 4 minus 1, it will be negative 7 over 4. Now, this is the derivative. If I want to find slope, I need to replace x with 1 in this question. After replacing x with 1, we will get the answer, negative 3 over 2. This negative 3 over 2 is slope. The rule, y minus y1 equal to mx minus x1 is going to be used because tangent line is a straight line and this rule is for straight line. That's it. We know the slope, it's negative 3 over 2. We know the point, 1, 2, it's given. Then only replace them. Y minus y1, it's y minus 2. Equal m, slope is negative 3 over 2. X minus x1 is like x minus 1. Simplifying this equation like this, it's the equation of the tangent line. In exercises 53 to 55, find the point, if any, where the tangent line to the graph is horizontal. That's a good question. Tangent is horizontal. As you know, tangent line is a straight line. If a straight line is horizontal, let's say this is a curve. If the tangent line is horizontal, what does that mean? Since we work on derivative, we relate any problem with lines to slope. And when we have slope, we can deal with it as derivative. Slope of horizontal lines is 0. Any horizontal line has the slope 0. Now, if this horizontal line is a tangent line, it doesn't change this fact. This tangent line has the slope 0. All right. Then what we do, We find the derivative. We know derivative is slope if we replace x with a number. But this time we don't know which x, but we know the slope, the result is 0. See how can we do this? Result is 0 means derivative is 0. What do we do? Find f prime x equal to 4x power 3 4x power 3 minus 16x. Derivative of 2 is 0. This is the derivative. Now it's equal to 0. F prime of x equal to 0, it means tangent line is horizontal. Tangent line is horizontal. Tangent is horizontal means slope is 0. Now solving this, 4x power 3 minus 16x equal to 0. To solve this, we can take 1x as common factor. We can take 4x as common factor. 4x, what's remaining? Here x power 2 is remaining, minus 4 equal to 0. Now I have 0 product. I have 4x multiplied by a bracket, result is equal to 0. This means x is equal to 0. If x is 0, 0 times the bracket, it will be 0. Or x squared minus 4 is equal to 0. If x squared minus 4 is equal to 0, this is difference of two squares. So it will be x minus 2, x plus 2. Equal to 0. If this part is equal to 0, if x minus 2 is 0, means x is 2. If x plus 2 is 0, means x is minus 2. Now we found 3 places where the tangent is horizontal. One of them is at x equal to 0. One of them is at x equal to 2. One of them is at x equal to negative 2. If we go back here, this function is x power 4. How is the graph of x power 4? Graph of x power 4 is like a W shape. If I draw a W here, how many critical points are there? There is one here, one here. So this tangent is horizontal, this tangent is horizontal, this tangent is horizontal. So it has 3 tangents. It has 3 points where the tangent is horizontal. Math makes sense. Question 54. 1 over x power 2. Again, we need to find where the tangent is horizontal. Let's find the derivative first. Let's rewrite first x negative 2. Derivative negative 2x. Now, derivative equal to 0 is where tangent is horizontal. Negative 2x equal to 0. X equal to 0. At x equal to 0, the tangent is horizontal. Question 55. By the way, let's check this x equal to 0. Graph of 1 over x squared is like this. Is this making sense comparing to this graph where the tangent is horizontal? Actually, since it doesn't make sense, following the steps, we got x equal to 0. But at x equal to 0, tangent is horizontal. There is no graph at 0. The function is not continuous at 0. This means, according to the calculations, we got 0. But this answer will be rejected because comparing to the graph, the function of the graph, the continuity, this function is not continuous at 0, means it has no tangent at 0. So this will be rejected. And the question, if you remember in the beginning, said Find the points, if any, if there is any, where the tangent is horizontal. This function doesn't have a horizontal tangent at 0. 55. fx equal to x plus sine x. F prime of x, for question 55, it's equal to 1. Derivative of sine is cosine. 1 plus cosine x. Now, derivative equal to 0. 1 plus cosine x equal to 0. It means 1 is equal to, it means cosine x is equal to negative 1. Cosine of x, at which value it's equal to negative 1? Graph of cosine is like this. Cosine of, in the exam you have calculator, but I want to show you. Cosine of 0 is 1. Cosine of 90 is 0. Cosine of negative 1, cosine of 180 is negative 1. Cosine of 180 is equal to negative 1. And 180 is an answer which is between 0 to pi. 180 means 1 pi. 180 in terms of sine and cosine is pi. So the answer is pi. Cosine of x is equal to negative 1. In calculator, you can write cosine inverse of negative 1. The result is 180. This question is given in terms of pi. Then we answer in terms of pi. 180 is just pi. So x equal to pi. In terms of sine and cosine, pi is 180 degrees. Question 56 and 57, there is a missing value, k. Let's do 56 and 57 will be your homework. I want to tell you some ideas about how to do it. Question 56. A function is given, x squared minus kx. K is missing. Y is equal to 4x minus 9. This is the equation of tangent. But we need to find the value of k to make this line tangent to the curve. Okay, we are going to equate two things. Firstly, find derivative of both sides. Derivative of both sides. Derivative of this side is 2x minus k. Derivative of this side is 4. We know derivative is slope. Derivative of 4 means slope is 4. We equate derivative of this equal to derivative of this. So 2x minus k equal to 4. This is equation 1. Leave this. Secondly, equate the equations. X squared minus kx equal to 4x minus 9. This is equation 2. Now we are going to solve these two equations like a system. What do we do? Here in the first equation, make k or x alone. Which one is easier? Here, k is easier to be alone. Negative k goes to the other side, become positive k. Positive 4 goes to the side, become negative 4. Now, k is equal to 2x minus 4. We got this information from the first equation. So since we got the information from the first equation, we cannot use the information in the first equation again. We got the information from this equation. Then we use the information in the other equation. Now instead of k, we write 2x minus 4. So it will look like this. And instead of k, we have 2x minus 4. X squared, as it is, minus, and instead of k, 2x minus 4. That's 2x minus 4. Next to the k, there is x. This is the x. Equal 4x minus 9. Now, in this equation, the only unknown is x. So this means the equation is solvable. If in one equation there are two unknowns, x and k, x and b, a and b, it's not solvable. But after simplifying, after putting the value of k in the other equation, we got one equation that has only one unknown, which is x. It is solvable. We spend time on it because it's solvable. Now, x times 2x is 2x squared. X times negative 4 is negative 4x. And this negative multiplied by inside, change the signs. 4x goes to the side, become negative 4. Negative 9 goes to the side, become positive 9, equal to 0. Now simplifying this, it will be a quadratic equation. The quadratic is like this. Negative x squared plus 9 equal to 0. Negative x squared plus 9 is equal to 0. If x is 3, 3 squared is 9. With the negative, negative 9 plus 9 is 0. If x is negative 3, negative 3 squared is 9. With the negative before it, it's negative 9 plus 9 is 0. So we got the two values for x. X equal to 3, x equal to negative 3. Now, since we knew the value of k in terms of x, when we put 3 in place of x, 2 times 3, 6. 6 minus 4, 2. So when x is equal to 3, k is equal to 2. When x is negative 3, put negative 3 in place of x to find k, we will get negative 10. So when x is equal to negative 3, k is negative 10. We found two possible values for x, two possible values for k, to make the line tangent on the curve. In the next question, you can do it. What you do first, we equate the derivatives. Derivative of this, we can rewrite fx as k times x negative 1. X is down, goes up, become negative. Then derivative is equal to negative k over x squared. It will be negative k x negative 2. X negative 2 goes down, it will be x power 2. That's f prime. On the side, slope is equal to negative 3 over 4. Now this is derivative. This is slope means derivative. We equate these. Negative k over x squared equal to negative 3 over 4. We can directly get one value of k. We can directly get 3. Since two fractions are equal, k is equal to 3, x is equal to either 2 or negative 2. For multiple choice questions, only this step is enough. They give you some values of x and k. The values of x and k should satisfy this. Negative k over x squared must be equal to negative 3 over 4. We can tell k is 3 because with the negative it becomes negative 3. We can tell x is either 2 or negative 2. But if we follow the steps like this, we will get the actual answers algebraically. That's a shortcut if there are multiple choices given as values of k and x. Okay, the other step that we are going to do is to equate the equations as they are. So we can call this equation 1 as we equated the derivatives. We can equate the functions themselves. The functions like k over x equal to negative 3 over 4 x plus 3. This is equation 2. In the first equation, make k alone, put the value of k here, then solve the system. This is the end of the session. Thank you so much for watching. Stay tuned to see the rest of the book.